So, how many people have attended that exam last week? Okay, is that clear? Question paper is normal. Interview questions are normal, and you can collect your answer sheets after the class and check where the mistakes was done. And please prepare. And we are going to conduct the next mock interview on the next Saturday, right? If next Saturday is Ramjan and something special is there, miss, it will be on Friday on, one day before on, right? So please plan accordingly. Now, let's start the session. So the interview questions also would be the same pattern. In the interview also, they'll ask related to statistics. If the exam was conducted on statistics or something, okay, in the face-to-face interview, the questions would be like that only. Whatever the questions I have shared you, right? Since we have conducted a small portion of the syllabus, so there are not much questions. So by the next week, we'll be completing the entire statistics part. And along with that statistics, we are also going to be completed that exploratory data analysis part also. So by that time, you'll get more number of questions. So next weekend, you'll have more number of questions and multiple sets will be there. And along with that, mock interview also will be conducted, right? Face-to-face mock interview, whoever has written very well in the exam, for those people, they'll conduct the mock interview. And for online students, randomly we have to choose. For online students, randomness. For offline students, credit, whoever has done very good. Means what exactly in the company happens, I want to have in the same, in this entire 4 months duration. So that once you enter into the company interviews, real-time interviews, you should not feel nothing new. You should be familiar. Everything you should be familiar of. Is that clear, guys? Done. So now let's start the session, today's class. So in the last class, we are discussing about the statistics, and within the statistics, we have discussed descriptive statistics and everything. Now, within the descriptive statistics, now the last concept of the descriptive statistics. What is the last concept of the descriptive statistics means? For example, we are having some data. Okay, let us take the temperature. Okay, temperature at Ameerpet at the 1 p.m. Okay, every day they have collected last 10 days records. We are having last 10 days records with us. And based on these 10 days records, we want to predict the next day record, right? Means to be more simplified, from 7 days, 7th April to today's date is 17th April. So to 17th April, we are having the data at 1 p.m. So every day at 1 p.m., they have collected the temperatures from 7 to 17, right? Now, from this, now we are going to conduct from 7 to 17, whatever we are having the data. Based on this data, we have to predict on the 18th, that is tomorrow's temperature. So they have given you only 10 days temperatures for us. Now, based on this, we have to predict. Now, generally what we'll do is by default, whenever you are having a single column, the prediction would be by default, it is mean. And this is a sample data. By default, it is a sample data. It is not a population data. So we are going to calculate the sample mean. We are going to estimate as a sample mean. Okay, because we are having only one column. If we are having two columns, then we are going to apply a different concept. When we are analyzing multiple concepts, then it will be different. But when we are analyzing only a single, that is univariate analysis. In the univariate analysis, that too with respect to you are doing on the continuous variable, the prediction will be only with respect to the mean. Okay, now the sample mean. So we are going to estimate the mean, which is nothing but sample mean X bar. Now this X bar, we are going to estimate. For example, the data is something and I have calculated the average. The average I have got as 28.9 degrees centigrade. Assume this is the average. Now, what is the probability that tomorrow the temperature is going to be 28.9 degrees? Can anyone? What would be the temperature? That the temperature will be to 28.9 degrees. 0, exactly. That is the answer. So the probability of a single continuous variable is 0. So for this point, whatever the value, single value, the probability is going to be 0. So probability cannot be estimated for a single point. So that is the reason we have to add an interval, some interval. Okay. Now, what is the interval we are going to add, miss? So, for example, 28.9, you are saying that, sir, tomorrow's temperature would be, let us take it as round figure to 29. Okay. So, sir, tomorrow's temperature would be 29 degrees. If it is exactly 29, you are correct. If it is 29.1, you are wrong. 29.2, you are wrong. 29.05, you are wrong. 28.95, you are wrong. 28.99, you are wrong. Sir, it is almost close now. Then you also predict in that way only. What I have to take right side, how much values you want, left side, how much values you want to me consider. Sir, okay, sir, take left side from 28 to 30. You take like this. 28 to 30. So if it is 29 also, correct answer only. 29.1 also correct answer only. 29.2 also correct answer only. Take an interval, plus or minus 1%, 1 degree. Okay. So for this value, whatever the 29 is there, for this value, add the plus or minus some error. Add some error. So that you'll get with an interval. Now, what is this means? Very simple. So earlier we have predicted, earlier whatever we have done is the prediction, whatever the prediction we have done is called as point estimate. Point estimate. Point estimate means single value estimation. This is called as point estimate. Interview question. What is point estimate? Right? In the notes, write only the questions. Don't write the answers. Answers, what I am saying, understand. Later after the class, you write on your own way. So that you will recollect, you will practice. Both the things will happen. Right? Now, what is point estimate? Point estimate means single point. Okay. You are estimating a single value like mean, median, mode, variance, standard deviation, something. Everything are single values only. You are estimating a single value means it is called as point estimate. For this point estimate, we are going to add some error. This error we can't add as per our choice. We are going to take the standard error. We are going to add some kind of standard error. That standard error is given by sigma by square root of n. By standard error means by using the standard deviation. So x bar plus or minus sigma by square root of n. Now we are having an interval. Now what is the interval? Using this, what is the interval now? That is x bar minus sigma by square root of n to x bar plus sigma by square root of n. This is called as your interval. This single value is called as estimate. When you add plus or minus some error, then it is called as interval. Now you are predicting with an interval. This interval is called as central limit theorem. This concept is called as central limit theorem. What is meant by central limit means you are focusing on the center value only, but right side, left side, you are adding some error. Your main interest is 29 only. Instead of saying 29, left side you are doing -1, right side you are taking +1. Main focus is 29 only, center value only, right? So this interval, whatever the interval we are going to estimate by point estimate plus standard error is called as central limit theorem. Okay, heading as central limit theorem. Now what is meant by this central limit theorem says that we have to do the point estimate. We have to do the point estimate plus or minus some standard error. That is nothing but x bar plus or minus sigma by square root of n, which is nothing but sigma minus x bar, this one, to x bar plus sigma by square root of n. This is called as interval. This is the central limit theorem. So you are going to estimate the tomorrow's temperature. Tomorrow's temperature is your point estimate. For that, you are adding the plus or minus standard interval. Right? Now, okay, sir. Now for this interval, for every interval, one probability will be there. As we know, for two values are there. You know how to calculate the probability between two values using the g-scores. First, you are going to convert them to the g-scores. After that, after converting to g-scores, you are going to calculate between two values what is the probability. You know how to calculate the probability. Means for every interval, certain probability will be there. Any interval you take, one probability will be there. 0.000000001 minimum. right? Some probability will be there for the interval. When you consider the single point, the probability is going to be 0. That is the reason never we are going to estimate any continuous variable with a single value. Always the continuous variable has to be estimated with a interval. If you ask what would be the price of this house, price of the house is a continuous variable. When you ask the house price, you can't say exactly 50 lakhs. You should not say like that. It would be between 48 lakhs to 55 lakhs in between. So anything you have to say, whenever there is a continuous variable, only interval has to get in the mind. Whether you are predicting, whether you are estimating, whether you are going to inferencing, whatever you are going to do, for continuous variable, only the interval. The reason behind that is for point estimate, the probability is equal to 0. That is the reason. From that reason only, this central limit theorem has came. Based on that reason, right? Now, okay, sir, for every interval, you are having certain probability. I want this probability should be exactly equal to 95. This probability also should be exactly equal to 95. I want to predict in such a way, this probability also should be equal to 95. Then what I have to do means, now whatever the interval you are having, that is x bar minus sigma by square root of n2, x bar plus sigma by square root of n. You are having this interval, right? Now what you have to do for this interval means, for this interval, you have to add the z value, means z of 1 minus alpha you have to add. Z of 1 minus alpha. Now, this if you add, now this is called as, this particular concept is called as confidence interval. Okay. Expected. Something will be today. Festival only. Guys, online students able to see the screen? Online students able to see the screen? Yes. So there is no problem for you. Yes. Just give me a minute. What's So confidence interval. Now, without understanding, don't write. What is the concept? First understand. Now, what is meant by first? 1 minus alpha. First understand 1 minus alpha. First, before understanding 1 minus alpha, first alpha. Okay, let's start with alpha. Now, what is meant by alpha? Alpha is nothing but your error percentage. Your error percentage is called as alpha. For example, if I'm considering 95% probability I want. 95% probability means what is the error? 5%. 5% is the error. So this is equal to 5%. Now 5% means 5 by 100, which is equal to 0.05. Now 1 minus alpha. 1 minus alpha is called as confidence. Confidence. 1 minus alpha is called as confidence. That is nothing but 1 minus 0.05, which is 0.95. Means with 95% confidence, you are predicting this is the interval. With 95% confidence, you are predicting this would be the interval. Now, here, now z of 1 minus alpha. Now, what is meant by z of 1 minus alpha? Now, z of 1 minus alpha is now z of 0.95. Open your z table. Within the z table, where the probability of 0.95 is there, that particular z value you have to substitute here. And you have to multiply with your error. Got the point? For example, you want to estimate with see, let us open the Z table. Okay, let us, instead of opening the Z table, let me open the so with stats dot norm dot PPF. PPF means point probability function, means point value. You are calculating the exact Z-score value. That is for 0.05. What is the value? Miss, it is saying that 1.64. Z value is equal to 1.645. That is the Z value. Now, for example, let us take an example like this. Okay, just give me a minute. Now, for example, you are having 10 records with you. For these 10 records, you calculated the X bar is equal to 29. And you calculated the sigma by square root of n is equal to 1. Right? Now, your central limit theorem. First, let us start with the central limit theorem. Central limit theorem is equal to, as per the central limit theorem, the 29 minus 1 to 29 plus 1. So this is from 30 to 28 to 30. This is limit of 28 to 30. But this will have certain probability. This value will have certain probability. What is that probability? Means that we have to open the, we have to check the Z-score value. And from the Z-score, again, we have to calculate it. Right? Now, here, for example, let us assume this, whatever the Z-score we are having. Now, let us take the sigma value. The sigma value is equal to 4. N value is equal to 16. Assume this is the value. Sigma is equal to 4. N value is equal to 16. X bar, mu, everything is there. Now, 28 minus mu, that is 29, divided by sigma, that is 4. 2, 28, 30 minus 29 divided by 4. That is x minus mu divided by. What is meant by Z-score? What is Z-score? Z-score is nothing but x minus mu divided by sigma. Now, what is here mu? 28. What is here mu means 29. What is the here sigma value? 4. What is here x? 28. 28 minus 29 divided by 4. That is minus 1 by 4. Next, z of x bar minus mu divided by sigma. That is 29. 30 minus 29 divided by 4. That is nothing but 1 by 4. So you are going to calculate from Z value minus 0.25 to plus 0.25. What is the area? So you are going to open the Z table and you are going to calculate from minus 0.25 to whatever the area you are having from minus 0.25 to plus 0.25. You are going to calculate. This area you may get anything. Any value you may get. Okay. Now, but I want to go exactly with 95% confidence. Now, 95% confidence you want, miss. Now, what you have to do, the same 29, instead of doing minus 1, we have to multiply with 1.645 into 1. And 29 plus 1.645 into 1. Right? So now, what happens? You are going to take x bar minus z of 1 minus alpha into sigma by square root of n to x bar plus z of 1 minus alpha into x bar by square root of n. Now what happens? 29 minus 1.645 to 29 plus 1.645. 29 minus 1.645, which is equal to 27.36 or 355, whatever it is, to 30.64. Now this interval, if you now calculate the interval, 100% it will be 95 only. Convert this one to corresponding Z-scores and again you calculate. Now the exact it will be 95. Right? Now, so now if you want a particular confidence interval with a confidence you want to predict, then we are going to add the confidence interval. Sir, For example, 95% confidence, 1.645. For example, I want to predict with 90% confidence only. 90% means Z of 0.90. You want for 0.90 only. Just calculate wherever in the probability, where the probability value is equal to 0. This one, that is here. I'm going to write 0.9. I got 1.28. So now this 1.28, I'm going to predict. I'm going to keep with respect, instead of 1.645, I'm going to take, instead of 1.645, I'm going to take 1.28. Now what happens? 1.28 means interval will be reduced or increased? Reduced. As the probability is low, if the probability is low means the range of the interval will be low. If you want high probability, automatically the interval will be high. For example, I want to predict the temperature tomorrow at Amirpet. I'm going to say that tomorrow's temperature will be from 0 to 60. 100% I'm guaranteeing. If it is not miss, whatever you want, I will do. If possible, I will write the entire Infosys company name also on your name. Right? Everyone knows tomorrow's temperature will be from 0 to 60. That is no need of data scientist. Even Lilliput also will tell this one. Right? Basic people also will tell that tomorrow's the temperature will be from 0 to 60. But as a data scientist, what we have to do is we have to predict with a good interval with a less range. Okay, predicting the less range, the range should be low, interval should confidence should be very high. Okay, so you have to predict in such a way, that the range of the range means the maximum minus minimum value. The range of the interval should be low and confidence should be high. Confidence means probability. Confidence means nothing but probability. The probability of occurring that one should be very high. The confidence should be high. This is the data analyst work. Okay, data analyst work. For example, tomorrow some earthquake we are having in a particular city. Okay, in some somewhere. Okay, some country, XYZ country, in that XYZ city. There's some earthquake is going to come tomorrow. Now they are going to predict that one. They are going to predict not with a single value. They are not going to say that, sir, tomorrow's the earthquake will be at exactly Richter scale of 4.6. They are not going to predict with a single value. They are going to predict with the interval. That too, they are going to predict with a confidence. Okay, tomorrow the vector scale is going to be from this much to this much. The Tufan, whatever the Tufan or something we are having in Andhra Pradesh or in Hyderabad or somewhere, it is going to be between 1 to 2. They are going to say everything in an interval. And we are going to get some kind of wind flow, this much kilometers per hour to this much kilometers per hour. They are going to say with the interval. They are not going to say with a single value. Everything they are going to estimate with the interval. That too, they are going to estimate with a confidence. And based on that confidence level and based on that interval levels, the necessary measures will be taken by the administration people like collectors and remaining others of that particular area. Okay, what are the required measures are required during the, for example, they are estimating tomorrow there is going to be some Tufan in Vizag, example. Okay, now immediately they are going to take the measures. Which type of measures they are going to take? Based on whatever the interval is there, right? Based on that, if they are expecting very high, according to that, they are going to take the measures. If the basic one is there, according to that, they are going to take the measures. Which type of measures they are going to take is based on the prediction. The prediction should be more accurate. Okay, so as a data analyst, they have to predict. This is the work of a data analyst. Okay, this is the work of a data analyst within the descriptive statistics, and this based on this only the inference statistics is designed. From this inference statistics, right? So we have to predict in such a way the range of interval should be low and confidence should be very high. How we are going to predict is based on the confidence interval by using the concept called as confidence interval. And from where you got this confidence interval is by central limit theorem. From where you got that one is based on the point estimate with error. That side and this side we are adding the some error.
That error we can't add as per our choice. We have to take the standard error. Standard deviation is the standard value. This reason it is called as some standards. Right? So let's see alpha into sigma by square root of n to square root of n. Right? Now here one of the important questions there. The most sometimes may require to take alpha by 2. Now when we have to consider alpha, by 2. This is one of the most important within the descriptive statistics. This is the final question of the descriptive statistics with this descriptive length. Right? Now what is this alpha by 2? When we have to consider alpha by 2 means if you are having an interval in between, then you have to consider the alpha by 2. Alpha means error. Right? Error percentage is 5, which is equal to 0.0. What is 0.1 out of which 50-50. Now I want in decide 5%, decide 5%. In between, I want 95. This should be 95. Now this side how much should be there? This side how much should be there? This side 2.5. This side 2.5. In this case, what is the alpha? Alpha is equal to 0.025. In this case, though alpha is equal to 0.025 also, you are predicting with 95% probability only. In this case number 2, let us take like this, where you want completely this one as 95. When this is 95, what is this area then? In this case, alpha is equal to 0.05. Got the difference now? Sir, whether this one has to be considered, this one has to be considered. How? That we are going to discuss. In which situation this one, or in which situation this one has to be considered, that only we are going to discuss in the inferential statistics. Right? So whenever you are having two sides the error, both the sides the error is there, then whatever the error is there, total error should be equally distributed on the two sides, because it is a symmetrical distribution. The error should be distributed two sides. If the error is completely one side, you can go with the alpha is equal to 1. Directly alpha. No need to divide by 2. Is that clear? Now, in the central limit theorem, particularly in the central limit theorem, obviously we'll have two sides because left side and right side. So in the central limit theorem, 100% you have to apply the alpha by 2 only. So if someone asks you the question, if someone asks you that predict with a 95% confidence interval, means x bar minus z of 0.975 value, at wherever the value you are going to get 0.975, means substitute here 0.975. This one you have to consider. Means 1.96 you have to consider, not with respect to 1.645. You should not consider 1.645. You have to consider 1.96. Why? What is the reason behind that? Because you are going to get a interval. Interval means two sides will be there. 100% in between only you are going to calculate. That side error will be there. This side error will be there. So if 95% confidence, for 95% confidence, meaning of 95% confidence means you have to take the z value at 0.975, not with 0.95. You have to take 0.975, z at 0.975. Is that clear, guys? The reason behind this? Clear? Right? So instead of considering z at 0.95, you have to go with the 0.975. Whatever the value is there. Simple, guys. Very, very simple. Okay. I will explain in a still more simple way. They are asking 95% confidence. Confidence interval. Confidence interval. That is important. Interval means confidence means this is called as 95% confidence. In the question, if they ask you the confidence word, simply you can understand this in this way. Interval means surely it is going to be in this. Whenever there is an interval, 95% confidence means automatically alpha is equal to 5%. Alpha is equal to 5% means alpha by 2 is equal to 2.5%, which is equal to 0.025. Right? So this is this is with respect to 2.5%. This is 2.5%, and this is 95%. Okay. Now you are going to calculate at z of 0.975. That is with respect to this. In this case, you are going to calculate alpha is equal to 5%. You don't need to divide into two sides, only one side. 5% is on one side only. Entire one side is there. So directly in this case, alpha is equal to 0.05. Don't divide. Now you have to consider z of 0.95 in this case. In the both the cases, 95% only. But in case 1, case 2. Okay. In the further, you'll understand. In the further, when I'm explaining the inferential statistics, automatically you'll understand very clearly. Still more. What is the reason behind that? And you will tell easily in which case you are going to take the both the sides, in which case you will take the one side. Not only this side, this one also is called as 95% only. This is also 95%, and this is 5%. In this case also, we have to go in this way only. One side 5% is there, miss, directly 5% you have to consider. Two sides is equal to 5%, miss, divide into two parts. Clear? Got the point? Now, which case this one, which case this one, which case this one, those things we are going to discuss. Okay, in the inferential statistics, we'll discuss. This is called as two-tail test. This is called as right tail test, and this is called as left tail test. Okay, don't get confused. One by one, you'll understand automatically. Just as of now, you have to understand alpha. Sometimes we have to take alpha, sometimes we have to take alpha by 2. Is that clear, guys? Now, that is with respect to central limit theorem and confidence interval. So with that, the entire descriptive statistics part was completed, right? And so already we have worked on the descriptive statistics with respect to this everything, whatever we have done earlier, everything we have done using the pandas. And if you want to calculate the p-value, if you want to calculate the p-value, calculate the probability using your g-score, miss, you have to write the CDF function. If you want to calculate the z-score based on the probability, this is your probability value. For this probability, what is the exact z-score, miss? This is the z-score. Then you have to use the PPF. To be more simplified for you, let me open the Z table. Still more simple. Okay. If I ask at what is the probability at Z equal to minus 1.4. If I ask this question. Now you are going to calculate at minus 1.444 means this one. So you are going to say this is the value 0.7493. 0.7493. This is the answer. Now I'm asking what is the Z value? Now I'm asking what is the Z value where the probability is equal to 0.7493. Where the probability is equal to 0.7493, what is the probability? What is the Z-score? Just you are going to observe where is the 7493, 9391, something, 0.074, 0.074. So 0.07493 is here, which is equal to, Z value is equal to minus 1.44. This is called as PPF. This is called as CDF function. From CDF function, you calculate the P value. From PPF, you will calculate the Z value. Reverse. Both are reverse. Is clear now? If you want, if you want, you can try the same question here. So if I keep minus 1.44, CDF of minus 1.44 means I'll get the P value. From this, I'll get the P value, which is equal to 0.07493. Is that clear? Now the same question I'm asking here with probability as the input, 0.07493 as the input I'm giving, and I'm asking what is the Z value. It is clear now? One gives the Z-score as the output, one gives the probability as the output. Just both are reversed to each other. From this table, if I say any particular probability, from that probability you can calculate the Z-score, right? Now tell me what is the Z-score at, tell me the Z value where the P value is equal to 0.95. 0.95. Now see here, 5048, decreasing. It is decreasing. Every time it is decreasing. So now we will open the positive table. Now in the positive table, increasing. So let us move on to the various 95. 92, 92, 94, 94, 94, 94. Yes, here I have got that is which is equal to 1 point. Got the point? Is that clear now? That value you have to take. Earlier I have told you, right? Z of 1 minus alpha means Z of 0.95 means you have to take 1.65. If you are going with directly alpha, the same question 1 minus alpha by 2 means Z of 0.975. Now tell me where is 975? 975, 975, 975. 975. What is the answer? Is that clear now? That you have to apply, right? So just based on your probability, you are calculating in reverse. Actually, generally, we have to calculate probability. For example, if I say the probability is equal to 1 by 2, this is my probability. I have given directly the answer. Now tell me what is the question, miss? So there with respect to 2 are there, A comma B, and you ask the what is the probability of A. You only created the question. Based on the answer, you created the question. If I don't know, if I ask the question and if I ask the answer, miss, that is one way. I'm giving the answer and I'm asking the question is another way. Two options, right? Now, still if I explain, miss, you will get confused. So this explanation is sufficient. Otherwise, it will lead to the overfitting. Right? Is that clear, guys? Anyone having any questions? Now, in the last class, we are done the pandas where we have extracted the data using a iloc and loc. And along with that, by how to extract the data using a single column. Only those part we have done and remaining part we have not done. Right? We have directly went into the statistics. So let us complete the balance part of the pandas in today's class. Right? Now, so I'm going to import the NumPy as NP, pandas as PD. And already we have done all these things. Directly, I'm going to load the data. From here, I'm starting. DF. And what is meant by df.head? Miss first 5 records. Tail miss last 5 records. Shape miss number of rows, comma, number of columns. And within that, you want number of rows only. How to calculate number of rows? That is a tuple only, right? Output is a tuple. For the output tuple, in the tuple first value, how to extract the first value? By using the index of 0. Just write the index of 0, you'll get 10. If you want the number of columns, write here 1. If you write here 1 means you'll get the number of columns. If you write 0 means you'll get, because the shape, the output of the shape is tuple. For the tuple, we are adding the indexing, right? Now, df dot size means total number of elements, that is 10 into 6, 60. df dot columns means what are the column names we are having. Similarly, df dot keys means what are the key names, nothing but column names once again. And if you want to rename any particular column name, you are going to write the df dot rename columns is equal to, you have to take as a dictionary and the old name and along with the new name. Key should be the old name, value should be the new name. So it is going to replace, the column names will be replaced, right? Now, sir, column names, okay, sir. For example, index names also there, na? Row names also will be there, right? Sometimes row names also will be there. If I want to replace row names means instead of columns, you have to write here index. Rows are called as index names. Columns are called as column names. Rows are called as index names. Index. They are called as index. Right? Is that clear? Next, D types. D types means it is going to give the different data types. And df.info, you are going to get entire details, whatever we have discussed till now. That is first starting with the shape. df.shape 10,6. The same thing you can observe here only. 10,6. df.columns. df.columns means it will give the column names. That also you can observe here only. Okay. And df.d types. df.d types means it will give the data type of each column. That one also you can observe here only. So a combination of these three is nothing but info. So you don't need to write every time the df.shape, df. That one, this one. You don't need to write directly. You can write the df.info. Simple. In one shot, you'll get it. So that is the reason it is called as concise summary. Concise information. Info means information. Concise means some basic information. Starting information. Right? And if you are having any missing values, how you are going to check any missing values means by using the df.isNull.sum. IsNull gives you true or false. Dot sum will give with respect to addition. It is going to add. Right? Now, how to access the elements by using the loc and iloc. Loc means with respect to name wise, iloc means index number wise. And we have discussed very detailedly about this one. And this is one of the most important interview question in entire pandas. In pandas, if they ask any interview question, means that interview question should be with respect to iloc versus loc. 100%. No doubt on that. If they ask at least one question from pandas, means that should be minimum is ilock and lock. Without asking this question, they'll not even ask another question. Right? That is such an important question because we are going to extract the data based on by using the lock and ilock. Right? So we are going to select the data as per our requirements. Right? To select the data, we require the options called as ilock and lock. Any one. ilock or lock. Any one. And if you write directly like this, df of age means it is going to extract a single column data. If you write the df of two columns means it is going to take the two columns. So just what is the difference between this one and this one means df of square bracket. Square bracket indicates that you are working on the index. And here you are writing the single column name. When you want the multiple column, okay, column 1, okay. If you want the multiple columns, if you write like this, column 1, comma, column 2, like this, if you write, now it will not understand. You have to take as a list of columns. Inside that, you have to take a list of columns. Whenever the multiple are there, list. Whenever single is there, single value. Okay. So in the help file, if you open the help file also, in the help file, it will say that either it should be the string. String means name of the column, or it should be int. Int means index number, or it should be list of values. If you're extracting multiple values, means list should be there. Either string, int, or list of values. Okay. So in the backend, they have written the code with respect to using if and elif. If, elif, elif. If they have given as the input as string means, accordingly it is going to work. If they have given the int means, accordingly it is going to work. If they have given the list of values means, accordingly it is going to work. In the backend, if, elif, it will be working. Okay. Is that clear? And apart from these three, if you give something like a tuple, you have given as a tuple. Let us change this one to a tuple, or some set. You have given some set. Okay. You have given as a tuple of values. Now, in this case, it is going to throw the error because it is not satisfying the data type. Input should be either string or int or with respect to list of values. You can't even give the float values because index numbers cannot be float. Indexing, either positive indexing or negative indexing, number ints are only possible, but no floats are eligible. So either in that way it should be there. Is that clear? It will throw the error otherwise. This is one of the most important and multiple times we are going to use. Without this, we can't work. Without this, we can't work even one project also. 100% we have to use this one. Means not exactly age and gender. According to that, we have to extract the multiple columns. Right? Now, df of age. And what is the difference between this one versus this one? This versus this. What is the difference means? This is output is series and this output is data frame. This output is one dimensional. The output is two dimensional. Okay. df of single age, if you write means 1D you are going to get, and the output will be the series. This is one of the most important. In the future, we are going to see the data cleaning. Okay. Means data cleaning we are going to start in the next week. From next Monday, the data cleaning will be there. So when we are starting the data cleaning, in that we are going to use with respect to sklearn library. In that we have to give there will be functions. Some functions are there. These functions will take the 2D array as the input, not one dimensional array. 2D as the input. For example, if you write df of age like this, it will throw the error. This one has to be rectified to df of like this. Okay. So some functions are created with one dimensional, some functions are created with two dimensional. Which function was created with what we have to learn? That one only we have to learn, right? All the functions we have to learn one by one, right? If it is one dimensional means you have to use one bracket. If it is two dimensional means you have to use double square bracket. Okay. Now, if you want to extract the output as a array means we are going to use dot values. Dot values will get as array, right? Now, next, we already discussed with respect to all these things again and again, no need of discussing. And set index, I already told you. Reset index also I have told you. Next, how to sort the values in a data frame means in a column. Okay, you are having a data frame that is tabular data. In that, you want to have all the data in this order. a particular data you want in the order. Let us take this original data set. There is this. Okay, you are having the data set in this way. Now, this age column is there. I want the age column in the ascending order or descending order. In the Excel sheet, what we are going to do is we are going to select the column. Okay, and here there is an option called as sort and filter. And we are going to click on this, and there is an option called as smallest to largest. Smallest to largest means ascending order. Largest to smallest means descending order, in which order you want. So for example, I'm selecting the smallest to largest, that is ascending order, and I'm going to click on the sort button. Now automatically everything will be sorted in the ascending order. Okay, it is working fine. What is the backend code? It is working. For this working, some code should be run right in the backend. What is the backend code? The back here, you are selecting a single column. Now you are selecting the column. If without selecting the column, if you ask like this, it will throw the error. For which column I have to do? So first we have to select the column. The selecting the column is nothing but df of age column. This is called as selecting a column. After selecting this column, now what you are going to do? You are going to click on the sort button. This sort button is not called as sort function. You are going to sort, right? So you are going to sort in the ascending order or the descending order. So df dot sort values, and you are asking by using the age column. For example, I'm writing age. Ascending is equal to true means you are going to get in the ascending order. So you are going to get all the data in the ascending order. Same data, whatever you are having here. Right? Same data. Now, if you do this one, same, that is age column, whatever the age column, ascending is equal to false means descending order means you are selecting this column, and in the Excel sheet, just you are going to execute with respect to sort in the largest to smallest, and you are going to click. Then automatically you'll get in the descending order, right? Just you are going to use in the descending order, the same. One is ascending order, one is descending order. For descending order, you have to write ascending is equal to false. There is no descending is equal to true. That option is not available. So whether that option is available or not, how I can know? Means we have to open the shift tab. That is help file. Whenever we are going to learn any new function, tomorrow, once you join in a company, there you may have to learn some new functions. Whenever you want to learn the new things, just that new things someone has created. We are not creating that one, right? This is not the user-defined function. Someone already created. That is an inbuilt function. So inbuilt functions means we have to learn how he has created. If you're not interested, means you have to create your own function as per your choice. If you want, you can create your own function. Otherwise, if you want to use his function, means you have to learn how he has created that function and for what purpose he has created and what are the different arguments name he has selected. Right? So where we have to give by selecting which column we have to do the sorting and whether we have to do in the ascending order or descending order. Is that clear? Next, how to add a new column. Some new column if you want to add, miss, how to add a new key within the dictionary. There is a dictionary. Let us assume dictionary is equal to dict. Dict is equal to, you are having P, physics 35. 35 physics. And you are having chemistry, C, 49. 49 C. Now you want to add the M is equal to 50. How to add M is equal to 50 for this? The syntax. D of M is equal to 50. This is the syntax, right? Same thing. DF of name, whatever the column name you want. Column name only the key name, right? Key name and column name both are same, right? In the data, in the pandas. So the same syntax, whatever we have used in the dictionary, we have to use here. That is with respect to the column name should be here. And right set the values, whatever the values. So here, how many values are there total in this data frame? 10 records are there. So 10 values you have to give. If you give only 7 values or 6 values or 11 values or 12 values, it will throw the error. Right? In this way, you can create that one. Sir, this is all the values we are writing manually. I don't want manually. For example, let us take like this. What is this? TB means total bilirubin. TB means total bilirubin. What is meant by DB? DB means direct bilirubin. So total TB, whatever the TB is there, total bilirubin is equal to direct bilirubin plus indirect bilirubin, right? So that is nothing but indirect bilirubin, that is TB plus IB. Now I'm having the TB value, DB value. Now I want IB values. How to calculate for this? What is for this particular patient? TB is there, DB is there. What is the IB? 0.6. For this person, what is the IB? 7.3 minus 4.1, which is nothing but 3.2. For this, what is the IB? Again 3.2. For this person, out of 1, 0.4 is the DB, the balance of 0.6 is the IB. Total is 1, right? Now I want to create that IB, a new column called as IB, using these two columns. That is the difference between these two. So what I'm going to do, DF of IB. IB is the new column. What I'm going to do is TB of DB, TB minus DB. Now what it is going to do is it is going to create a new column like this. First right side part will be executed. Right side, what is right side part? This one. So from this, it will be subtracted. From one column, it will be subtracting another column because it is a pandas. Pandas was designed based on the NumPy. NumPy was designed based on the for loop. So automatically for each and every value, it will work. For each and every value. First this one, followed by this one, followed by this one, followed by this one by one. I told you in the NumPy, A is equal to 1, 2, 3, 4. B is equal to 9, 6, 4, 9. Now A plus B means it is going to take in the same position, whatever the values are there, those both will be added. This is not the list. This is NumPy array. I have not given the commas between them. So now automatically the value is 10, 8, 7, and 13. For each and every, in that particular position, whatever is there, it is adding. Similarly, A minus B. In that particular position, whatever is there, it is going to subtract. I'm going to subtract the same thing. Okay. Pandas was designed based on the NumPy. Okay. Now, how to drop a column? How to add a column we have seen. Now, how to drop? How to drop a column is df dot drop IB axis comma 1. Now, what is meant by axis is equal to 1 means in pandas, axis is equal to 1 refers to the column. Axis is equal to 0 refers to the row, which is opposite to the NumPy. Just it is opposite to the NumPy. Okay, in the NumPy, axis is equal to 0 means column wise, axis is equal to 0 means row wise. Okay, here axis is equal to 1 means column wise, axis is equal to 0 means row wise in pandas. In NumPy, it is just opposite. Now, what it is going to do, df dot drop IB. You are going to drop the IB column where axis is equal to 1. Means column wise, it is going to check in the column names. Is there any IB value? Yes, IB is there. So it is going to drop this column. Means remove, delete. Drop means nothing but delete. It is going to delete that column if it is available. If it is not available, for example, I'm asking a column name called as SRK. It is available as any column name SRK? No, it is going to throw the key error. That particular key is not there. What is meant by key? Column only, right? Keys are nothing but columns. So key error, key SRK is not found in the axis. Means axis is equal to 1 means column wise, there is no name called as SRK. So if, for example, IB is available, so what it is going to do? It is going to drop. Now, after dropping, right side, once everything was executed, again, it will be stored in the DF. I'm going to create in the original only. So miss in the original itself, it is going to remove. Now I'm going to get the DF miss without IB. Is that clear? So first right side part will be executed, followed by left side part. Now, same thing I can write in one more way also. Same thing I can write in one more way. That is DF dot drop. Okay, same to same. Okay, I'm dropping the column called as name, comma, axis is equal to 1. I'm writing axis is equal to 1. What it is going to do is it is going to drop. What it is going to drop? Name. Okay, name is dropped. Now, if you ask your DF, now what is the DF it is having? Can anyone tell what is the DF? DF will have the name column or not? Yes or no? Yes, because here you have not saved that one. You have not saved. Sir, since not saved, but it is why it is showing, then why it is showing this one? Because in the Jupyter notebook, last line will be automatically printed. In the Jupyter notebook, last line will be printed. That is the reason it is showing. For example, instead of this one, if you ask down, if you write A is equal to 2, why it will print that one above line? It will execute, but it will not even print also. Since it is in the last line, it is printing by default. Right? Now, so in this case, it is just printing, not saving. Now I want to save in the original data frame. Now what I have to do? I have to write df is equal to, I have to write like this. Or second option is there. The second option is in place is equal to true. Second option is in place is equal to true. In place is equal to true means in the original only do everything. Okay, in place. In place means original one. Do this operation in the original one. So it is going to do in the original one. And now what is the df means? Without name. Name will not be there. Sir, if you write, sir, if I write like this, let us take like this. df dot drop. Okay. Name column I am dropping. Axis is equal to 1. Okay, up to here it is common. If I write and after that if I store like this, this is option number 1. Option number 2, df dot drop name column with axis is equal to 1, in place is equal to true. This is second option. Both are same. Either of anything you can use as per your choice. Whichever you feel easy, that is the best option. Just you have to see whether in that function in place option is there or not. If the in place option is there, means it is applicable. In place option is not there, means it is not applicable. In place means wherever it is in place word is there, that is means do in the original one. It will replace in the original one only directly. The operation will be done in the original one. In this case, you don't need to write separately left side the data frame. Automatically it will do in the df. Now, what is the difference between the which one we going to use means here after dropping, if you want, you can create into a new one, but here you can't create a new one. It will drop in the original only. You can't create a new one. Separately, df and df1 will be possible in the above case. But in the below case, in the df only, everything will be dropped. Right? So, choice is yours, whichever you feel. And one more option also is there. Third option, option number 3. df dot drop columns. You have to write the word called as columns is equal to list of name. Only one column now, and close it. Now this time you don't need to write axis also because directly you have to mention the column word. Either you have to write column name, column word or axis, any one. Or fourth option, df dot drop columns. In this case, if it has to be saved means you have to save in the df. Column is equal to columns. Columns is equal to list. Whether it is a single or multiple also list only. Comma, in place is equal to true. With axis, either axis word or columns word, any one. With in place word or otherwise is equal to word, any one. Choice is yours. Everything are same answer. Finally, 4 of them will give the same answer. Is that clear? Whether you are using this one, this one, this one, this one, anything will give the same answer. No. Function was created with the keyword argument called as columns word. So whatever the function was created, we have to use those keywords only. We can't create our own keyword because they are inbuilt functions. They are not user defined. Right? Now, same with respect to how to drop the multiple columns. Here one column now. Now in this case, df is equal to df dot drop. Here you have taken one column. If you want multiple columns, what you have to do? List of column 1, column 2. Axis is equal to 1. How many columns you want? You write all the column names. Infinite. Absolutely no problem. Second option, df dot drop. Instead of writing single column name, take the list of column 1, column 2. And axis is equal to 1 with in place is equal to true. Now this time is equal to no need. You don't need to use the operator. Now in this case, already columns name is there. Column 1 is there. Column 2 is there. Column 3 is there. Column 4 is there. Column 5 is there. Column 6 is there. Column 7 is there. Column 8 is there. Column 9 is there. Column 10 is there. Column 11 is there. Column 12 is there. Column 13 is there. Column 14 is there. Column 15 is there. Column 16 is there. Column 17 is there. Column 18 is there. Column 19 is there. Column 20 is there. Column 21 is there. Column 22 is there. Column 23 is there. Column 24 is there. Column 25 is there. Column 26 is there. Column 27 is there. Column 28 is there. Column 29 is there. Column 30 is there. Column 31 is there. Column 32 is there. Column 33 is there. Column 34 is there. Column 35 is there. Column 36 is there instead of writing one column, you have to continue with the multiple column names. In this case also multiple column names. Wherever the single column name is there, you have to write multiple column names list. You have to take as a list. Is that clear, guys? Got the point? So in that way, we can drop the columns. So next option is how to drop the multiple columns. If I want to drop the two columns, that is TB and DB. So I'm going to take as list axis is equal to 1. So it will be dropped. After dropping, I'm storing in the DF1, not in the DF1. Okay. Now, if I print the DF, what is DF? DF will be the above one only. It is not going to impact on the DF, original one. It is going to have separately DF1. DF1 will be separate. In the DF1, it is not available, but in the original DF, as it is, original DF is not going to impact. Is that clear? Now, similarly, how to drop a row? How to drop a column we have seen. Now, how to drop a row? Very simple. Write the row names. What are the row names? Axis is equal to 0. Wherever the column names are there, instead of you have to write the row names, not the numbers, names. By default, numbers and names are same by default. Okay, but you have to write the names. So for example, I'm writing the name, which is nothing but, for example, I'm writing like this, 0. Name is 0. Okay, 0 will be dropped. The first record will be dropped. If you want to drop multiple names, what we have to take? List. That's it. Then particular rows will be deleted. Those row names will be deleted. For this, what is the second option? Wherever the word of columns is there, instead of that, you have to write the index. Instead of axis, if you're not interested to write the axis word miss, then you have to write the word called as index. Index is equal to either axis is equal to 0 or index. Axis is equal to 1 or column names. Anyone. Okay. Sir, why they have created these many options, sir? In a flow, they have created. In a flow, we are also learning. But in a flow, whichever you remember, that one only remember. Only one option you remember. Don't get confused with the 4 options. After practicing for multiple times, automatically. First time when we listen to multiple options, automatically there is a chance of confuse. So first time you understand only one concept, whichever you feel easy, remember only one. Okay. That one only, whatever you are remember, one out of 4 options, one. That one only you practice for 4 to 5 times. One day will be there. You'll easily remember that one. Now you try with the new options. The old one is already strong. Now you try with the new one. Okay. Is that clear? Now, sir, at a time I will practice like that, miss. Choice is yours. As per your choice. Right? In generally, what I will use, if you come to me, what I will use, miss, I will remember only one option. DF of drop, and I will write the list of names. If it is single also I'll write list. If it is multiple also I'll write list. And after that, I will write the axis. Then I will write in which one I want to say. This is my favorite option. I'll remember only one option so that no confusion. Okay. I'll always use this one only. If it is row names means I'll write row names, column names means I'll write column names. If column names means axis is equal to 1, row names means axis is equal to 0. For me, every time this is fixed. Whether column names or row names are that only difference. But this is only fixed. And why I will use this one instead of in place is equal to miss. Sometimes I may require to store in the new one. I don't want to disturb the old one. I want to save the old one. Okay. So in that case, I'm going to use like this. Is that clear? Now, next, what is the next option? Means duplicates. How to add a column we have seen. How to add a with respect to how to remove the columns we have seen. Single column we have seen. Multiple columns we have seen. Similarly, single row, multiple rows. How to delete. How to extract also we have seen. How to add also we have seen. Now let us move on to the duplicates. Now next option is called as duplicates. So in my data set, is there any duplicate records? Means what is meant by duplicate? Duplicate means complete record to record as it is will be there. Record to record, not single value. Not single value. Sir, 65, sorry, 72 here. Let us assume here 72 is there. 72 matching now, not with single value. Entire record. This record should be as it is same. Then it is called as duplicate. Not with respect to initial one. So if you are having anything like that, then it is called as duplicate record. Now, out of duplicate record, the first one is called as original record. The second one is called as duplicate record. Okay. So here I'm having this one. This is duplicated. From this, it is duplicated. So now automatically, if I ask df dot duplicated, the third record was duplicated. Sir, why you can't assume the second record only duplicated? Because first it will come to the first row, first row. First row, it will compare to the previous rows. What is their previous rows? Nothing is there. So no problem. First row, never it will be duplicated. In and never it is possible because it is not going to compare. Second row means it will compare only with the first record. It will not even compare with the any one of them. This record, now this record will be compared with the first one, and at the same time, second one also it will compare. Now third one, it will compare with the first one, second one, third one. This record will be compared with first one, second one, third one, and fourth one. It is going to compare in that way. So when it is comparing, automatically when this particular record comes, when it is comparing with this one, it is not satisfying, but this is satisfying. So it is called as duplicated. So the third record is duplicated in this case. So total how many records are duplicated? One record. Now how to get that one? Dot sum, just by using dot sum. So total number of duplicates means dot sum, which exactly record is duplicated means just you have to ask df dot duplicated. Then it will show the whichever the records are satisfying that one. True, wherever the answer is true, it will show. Right? Now dot sum is it will show the total number of duplicate records. Sum, it will give the sum. Next, now what we have to do with the duplicates? Only option is drop them. Nothing, drop them, blindly drop them. Nothing we can do with the duplicates. Duplicates means, for example, if I explain one example, if you're asking the question, sir, I'm having a doubt. Again, I'm explaining the same example. Again, this time you are asking one more time. Again, I'm explaining the same example. Without changing the example, I'm explaining the same example. Means I'm forcing that example only to understand. Not understanding the concept. I'm forcing not the concept. I'm forcing the example. If I'm forcing the example, what happens means you'll understand the example. If I force the concept means you'll understand the concept. So what happens in the duplicates means it will force to learn the examples. What are the records are there? The records will be understood by the machine. So the same record every time it will by heart the same record multiple times. What happens means the machine also will be by hearting. Machine also will by heart. Machine will by heart is called as, in technically it is called as overfitting. Overfitting. The concept is called as overfitting. Overfitting means by hearting. By hearting means, for example, if I do the mock interview. In the mock interview, can you explain the mean with an example? Means, sir, 1, 2, 3, 4, 5, sir. Average is 1 plus 2 plus 3 plus 4 plus 5 divided by 3. Divided by 5, which is equal to 3. Right? Whatever example I have told. You can't explain 6, 7, 8, 9, 10. Huh? Same example 1, 2, 3, 4, 5. You have to tell. Huh? Same example of 1, 2, 3, 4, 5. As this example you have to tell. Huh? You can't explain with a new example. Huh? If I ask, can you explain a central limit theorem example with Miss? Sir, temperature Amirpet, sir. Hey, temperature and Amirpet only example. You can't take the other example. Rain, for example, you can't take. You can't take traffic example. You can't take any other examples, sir. Right. Only Amirpet temperature only required. Huh? You are by-hearting the example. That is called as overfitting problem. Okay, machine also will do the same. Properly, we have to train the machine. Otherwise, it will also by heart. Right? So duplicates are there means we have to drop the duplicates. Simply, we have to drop the duplicates. So that particular record will be dropped. Right? Now, whenever there is a duplicates, just we have to drop. Sir, if we remove duplicates, that it replaces the none empty. No. So duplicate means as it is. So for example, here none is there means here also should be none. For example, here none is there and here 2 is there. Then it is not called as duplicate. If one record is different also, it is not called as duplicate. As it is complete, it should be there. Ditto. Then only it is called as, simply to say, Xerox copy. Xerox copy means as it is should be there. Okay. Now, missing values. Missing values means already I have told you. If there is any missing values in the data set, now what we have to do? Now for missing values, what we have to do? Means how to check the missing values that we are going to use is NA dot sum or is null dot sum. I have told you either is null dot sum or is NA dot sum will give the total number of missing values. So in this data set, 2 missing values are available. And if you want to drop those 2 missing values, then you are going to use the drop NA. Drop NA is wherever the missing value is there, that entire record will be dropped. Okay. Duplicate directly saved in the original one. After dropping, you're asking. If you're asking after duplicate, after dropping this one. So just check. If so here, again, DF is having the everything. So unless you save that one, it is not going to save. So you have to write DF is equal to DF dot duplicates. Then only it will be replaced in the original data. Right? Otherwise, just it is printing only. Is that clear? Nothing will be saved. Unless you write nothing will be saved. By default, it is not going to save nothing. Drop NA also will not be saved. Nothing will be saved. Unless you write. Either you have to write in place is equal to true or you have to assign to a DF. Right? Drop NA. Drop NA is wherever the duplicates are there. So for example, I'm having the duplicates DF. If I print the DF. So here, 4th record is having 1 missing value. 9th record is having 1 missing value. Option number 1 to drop the missing values. For dropping the missing values, what is the function we are having is drop NA. Drop NA is drop the null values. NA is not available. Which are not available, drop them. It is going to drop the entire row wise. It is going to remove the row wise. Sir, I don't want to remove row wise, sir. I want to remove column wise. Whatever the column wise is there, you know already how to drop the columns. You have already checked in the each column, whatever the missing values are there. You already checked this one. Within that, you want to drop any particular column is just drop that one. Right? So when we are going to drop, so if there are missing values are there, if in your data set missing values are there, we are having 2 options. Option number 1 is called as remove. Option number 2 is called as replace. 2 options are there. One is called as remove and one is called as replace. When we are going to remove, when we are going to replace. Remove when we are going to do miss if the missing values percentage is greater than 30%. 30% of the data is missing. Then we are going to drop. That particular column we are going to drop. Sir, how to get this percentage, sir? Very simple. Here 2 records are there out of 10 records. Total 10 records only, right? Divide by length of DF. Take with length of DF. You'll get with respect to percentage. If you exactly want into 100 also, you can do into 100. So 20% of the data is missing here. 2 records out of 10 miss 20% of the data. Like that, for everything, you are going to calculate the percentages. For every column, what is the percentage of records it is missing? Just calculate the percentage. And once you calculate the percentage, whichever the percentage is greater than 30, drop that one. Okay, 30% of the data is a miss, drop. Now, if it is less than 30, now what we have to do? Then, best option is to, instead of removing, replace. Why? Why should we not do the remove? Why for more than 30% only we have to remove? Less than 30 also, why we should not remove? Removing is very simple option. Removing the data is very simple. Gathering the data only difficult. Collecting the data is difficult. Removing the data is easy. Right? Data is called as new oil. Okay. New oil means not sunflower oil. Okay. New oil means in terms of nowadays with respect to, we are not based on that, the business, we are going to get the business. Based on the data only, the business will be there. Right? Now, here the data is more important. So since the data is more important, we should not drop that one. Right? So if whenever there is a less than 30%, don't drop that one. You have to replace. Now, what we how we have to replace? First option is remove. When we are going to remove is when more than 30% of the data. Okay, we are going to remove. Now, when we are going to replace. Replace when it is less than 30%, we are going to replace. Now, how we are going to replace? Option number 1 is called as based on your research. Based on your research, you have to identify what would be the value. Generally, what would be the value in that position that you have to work. This is option number 1. Option number 2. collect the data from the team. Whoever has collected the data, they have missed that one. Ask them, hey, here the data is missing. Are you having the data with you? For example, I want to predict the data scientist salary. Okay. Data scientist salary. We want to predict. Now, in that, one of them is called as interview score. One of the column is interview score. Based on your interview score, we want to predict the data scientist salary. Now, one of the record interview score is missing. And who will do the interview generally in the company? Some XYZ person will do. Now we are going to ask him, hey, you have done the interview for this XYZ person. Please submit the, what is the interview score? We are missing that value. Please submit the interview score. And we are going to collect the data. This is one option. Which option we have to choose means that entirely depends on the data set and the situation. For example, the person, whoever has interviewed, he has left off. He has went away. He is no more working in that company. Then we can't call him, hey, you have done the interview at that time now. Have you noted it somewhere in your mobile phone? Is there please send me the WhatsApp? We can't ask like this, right? If the person is side to you only, sitting side to you only, just yesterday only have done the interview now. What is the score? You'll ask like this. That situation, this situation, how I can say now only? That depends on the situation. In that company, in that project, in that situation, whatever is applicable. Accordingly, we have to react. Right? Now, this is based on the collected from the team. Third option, replace with statistical value. Replace with statistical value. That is either mean or median or mode. When you have to replace with mode, means if it is a discrete variable, for discrete variable, mean only mode only applicable. Mean and median both are not applicable. Only mode is applicable. So for discrete variable, apply the mode. Now for continuous variable, mean and median are available. Now which one we have to use? If outliers are present, mean is impacted. Already we have seen that one. If there is a outliers, it is going to impact the statistical analysis. Mean will be impacted, range will be impacted, standard deviation will be impacted. Already I have told you this one. So missing, if outliers are available, we have to use the median. If outliers, if there are outliers in the data, replace with the median. No outliers, then replace with the mean. Right? Sir, how I can know whether outliers are there or not? Miss, data cleaning process will be done after doing the EDA. That is statistical analysis. After completing that one only, you will come here. First, you have to complete that one. Directly, you are not going to enter into the directly data cleaning. First, you have to complete that one. After that, you have to do this one. Right? So, what are the options, miss? So, for all these options, function is common is called as fill NA. Where is that? Fill NA. Fill NA. I'm going to fill this value with 4.5. Miss, what are the values are there? Missing values are there. So, what are the missing values? Miss, this value. In the 4th record, this value, and the 9th record, this value. These both values I'm going to fill with 4.5. So it is going to be filled with 4.5. 4.5, 4.5. Now, how this 4.5 you have got? That is the question. How? One, based on your research. Okay, generally, this is the patient miss. Generally, his TP value will be in this range. If you know about that particular data, about that one, you are going to estimate. Right? Now, for example, if I ask you, what would be this water bottle price? Without water, empty water bottle price, what would be the price generally? You will have in your mind some value, right? That value you are going to replace. How you got that value, miss? Who told you that value? Who told you that value? From childhood onwards, you are doing the shopping now. You have seen the shopping, you went for shopping, you have done the shopping, something you have done. So you are having some basic idea on that. That is called as research. Okay, in this example, this is very simple example. If I ask the same question with respect to what would be the generally, how many of you will play the cricket match? Cricket. Generally, how many will play? Right? Now, what is the diameter of this cricket ball? What is the diameter? Taking the ball and throwing on the wicket, so you know. Something will be there, right? If it is missing, it is not a fixed value. It is not a fixed value. If you want, you can try after the class, you check with the things. It will not be the fixed value, right? Sometimes it will be, but it can't be more difference. The variance is very slow, very small. The variance and standard deviation is very small, right? So that we are going to do some kind of research and we are going to replace. Sometimes we may do the research. Sometimes we may get the values from others. Sometimes we are going to directly replace using the statistical values. With what you are doing, that note you have to write. With why you have selected that one, the reason you have to write clearly. That reason should be satisfied by your seniors, right? Otherwise, why you have written 4.5 means I'm interested. My feeling says time pass. If you say like this means they'll also say that my feeling says that you go out. Okay. So anything if you say means statistically should be proved, either statistical or research, using the research. You have to say that I have seen in the research papers, articles, something this one. So based on that, I have replaced the values. You can't say, you can't take the arbitrary value as per your choice, right? The function is fill in A. Common function is fill in A. With what value you are going to fill, that is the question. Is that clear? And similarly in the fill in A, we are having in place is equal to true. In place is equal to true means you don't need to write the is equal to side df, right? Is that clear? Next, most important in entire pandas, not only in entire pandas, in entire data analytics, this is the most important concept. Entire data analytics on this one only. Data analytics means the concept means data analytics. That is the one, right? This part we are going to discuss in the tomorrow's class. Is that clear, guys? So please practice till whatever we have discussed till today. Please practice everything and try to do and take some small data set as per your choice. You only work on that particular data set. Try to add something, try to delete something, try to extract something. You create on your own data set. You can't create a data set, two columns and 3 columns. Name it as SPU, column name. What are the names you want, you create. Inside that, what are the values you want, you write. One column take with respect to continuous variable. One column take with discrete count. One column take with discrete categorical. So different columns of different data types are there, miss, so that you'll understand. Try with that. Is that clear? So this we are going to discuss in the tomorrow's class. Tomorrow's class is one of the most important class. Don't miss it. And if you understand this one, data analytics part will be easy. And based on that, we are going to do the inferential statistics. We'll move on to the inferential statistics. Once inferential statistics is completed, Matplotlib and Seaborn, that is exploratory